All right. Welcome to Seattle Atheist Church. At Seattle Atheist Church, whether you call yourself an atheist, agnostic, secular humanist, freethinker, whatever you like to call yourself, you are welcome here. At Seattle Atheist Church, we are founded on the principles of scientific naturalism and secular ethics. Truth claims are attempted here, and we stand ready to revise our thinking in light of new information. We attempt to be excellent to all conscious beings, and we believe in good because good works in non-mysterious ways. If all of that sounds good to you, then you are in the right place. Before we get started this morning, I have a few quick announcements, okay? So the first one is I want to say thank you so much to people who have donated. Your donations help make this church possible. We have 4 different ways to give. So if you see Jack, who's right there in black, he has the 4 square credit card processing thing if you want to donate here. That way, there's cash jar. You can go to seattleatheist.church and click the donate link, and also, of course, there's the meetup chip-in thing. So all of that is possible, and I want to just say thank you very much because it's how we keep this whole thing going. Next Saturday, we have the Secular Saturday Social at Browers in Fremont. So please come out for that. It's at 2 o'clock, and that is going to be happening. And then next week, we have a talk on Sam Harris's book, The Moral Landscape. If you're interested, please come, whether or not you've read the book. I also want to get everybody signed up for our secret Facebook discussion section. So we have a public one where we're going to start posting a little more, I think. But there's also a secret one if you would like to, if you kind of want to go under the radar, but still be able to keep in touch with people who are here. I have this. I'm going to be taking people's names. If you want to give it to me, I'll put you in secret Facebook. And then starting next week for a year and a half, they have asked us to only park in the north parking lot. And then, that's north? Okay. Perfect. So right there on that parking lot. So it's okay today, but starting next week, that is our parking lot for like a year and a half. So there still will be plenty of free parking, but I just want to warn you that that's where you want to park if you don't want to get towed. So, okay, this is part 2 of a talk that Mickey started last week, and it was so good that we were just like, please, he said, have more, maybe I could give it, at some other time in the future, and we said, can you come next week? So, without further ado, come on up and get started. Thank you.
Hello, everybody. I'm Mickey Phoenix. Like no other atheists in America, I'm a software engineer by trade. And this is the second half of a talk on why do we believe. The focus of this half of the talk is why do we believe science? And what does it mean to believe science? I'm going to start with an often abused and misunderstood phrase, scientific consensus. Now, what is scientific consensus? Is it groupthink? That's a rhetorical question, by the way. Is it groupthink, where all the scientists toe the line and agree with the scientist leaders because that's the way you advance in science? Is it something that's only visible in the lens of history? The scientific consensus tells us that Galileo was right and the Pope was wrong? Is scientific consensus just a buzzword that means, no, whatever I say it means? Okay? The answer is scientific consensus is an imprecise and very real metric of percent agreement among scientists with knowledge in a field. And I specify scientists with knowledge in a field for a very good reason. There are politically controversial questions that science can answer, where the losing side, and I use that term advisedly, where the losing side says 2,000 scientists agree that the losing side is nonetheless the truth, and virtually none of them are in the fields in question. It's amazing how easy it is to get a mathematician or a physician to sign on that anthropogenic climate change isn't happening.
Anthropogenic?
Anthropogenic. Anthropos, mankind. Genic, generated, caused by. Anthropogenic climate change, used to be known as global warming, is the idea that human activity is altering the world's climate. Spoiler alert,
it is.
Human activity is altering the world's climate. Okay? Now I just made a statement of fact. I didn't say, I'm pretty sure, I think. I didn't say some scientists say. I said, human activity is altering the world's climate. It's possible that I'm wrong. Because sometimes science is wrong. But science says human activity is altering the world's climate. And that's an important thing to know. Science said at one point that everything orbited the Earth. Everything went around the Earth in great big spheres. Everything went in circular paths around the Earth because circles were perfect. Now, that was in fact the scientific consensus of the time. And that didn't make it true. But it made it the best knowledge that science had at the time. There's a difference between what science knows and the truth. You guys aware of this? Science isn't magical. Science does not have a divine source for its knowledge. Science does not get special telegrams from God. Religion gets special telegrams from God. They call them the Bible or the Quran or the Bhagavad Gita or whatever else their holy texts happen to be called. But what they are, or what they're claimed to be, is special telegrams from God that contain absolute truth. Science does not get telegrams from God. Science walks along and finds God's discarded Snickers wrappers, if you will, and goes, someone who liked candy walked by here. I see a Snickers wrapper. Okay? Maybe science walks along and goes, I've run into 137 Coke cans and not a single Pepsi can. Whoever was walking here seems like they liked Coke better than Pepsi. Good to know. Doesn't get a special telegram saying, God loves Coke. Pepsi is of the devil. Okay? So science will sometimes say things, not just scientists, but the scientific consensus, the aggregate knowledge of scientists worldwide, will sometimes say things that just ain't so. Okay? Classic example, Newtonian mechanics. Newtonian mechanics says F equals ma, force equals mass times acceleration. Newtonian physics is what we use to decide how much to angle a road for cars that are going to go a certain speed on it. How many people here think that Newtonian physics is a robust and well-supported scientific theory? Are you aware that Newtonian physics is wrong? When you are 6 centimeters from the event horizon of a black hole, Newtonian physics completely breaks down. It's not just maybe Newtonian physics is wrong. Newtonian physics is flat out wrong. In a very, 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 very tiny percentage of cases involving travel near the speed of light or gravitational gradients near vertical. We don't run into these on Earth very often. If you're trying to plan a road, you can ignore relativistic physics. You can completely ignore any physics done since, any large-scale physics done since 1905. Because 1906 was when Einstein started all of the stuff that led to both relativity and quantum mechanics. Go Einstein. Because the fact that Newtonian physics is in some edge cases wrong is irrelevant to the fact that it is in every case you will ever encounter walking around on Earth, right, and very useful, and much simpler. If you take so why don't we look at Einstein and go, wow, what a visionary, he showed us that stupid old obsolete Newtonian physics was just plain wrong. Well, if you take Einstein's equations and you solve them for the case where speeds are a very, 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 very tiny fraction of the speed of light, and the gravitational gradient is relatively shallow, guess what you end up with? You end up with Newtonian physics. Einstein's equations, the non-Newtonian physics, the relativistic physics of Einstein, indicated that yes, Newtonian physics is wrong in some edge cases, and right in the cases that aren't those edge cases. It builds on what was there before. It doesn't just throw it away, even when it proves it wrong. Newtonian physics was justifiably the scientific consensus for a couple of hundred years. It explained a lot of things. It matched experimental observations. Do you know how hard scientists had to look to find a problem with Newtonian physics? It's the orbital period of Mercury. Mercury moved at the wrong speed. Very slightly the wrong speed. And it's hard to observe Mercury because it's really close to the sun. You basically have to watch Mercury during eclipses. All right? And sure enough, after scientists spent hundreds of years trying to disprove Newtonian physics, in spite of the fact that there were all the, you drop a rock and you time how long the rock takes to hit the ground from different heights. Newtonian physics confirmed. Right? You roll a billiard ball into another billiard ball and you measure how much they rebound. Newtonian physics confirmed. Right? And yet scientists, individual scientists, still kept looking for more and more extreme cases. Because what if Newtonian physics only applied on Earth? What if Newtonian physics only applied in our solar system, right? And what they found out, sure enough, was that when you looked closely enough, far enough, in a specific enough circumstance, which was a small planet orbiting very close to a very large star, Newtonian physics didn't work. The funny thing is, scientists did not publish Newtonian physics obsolete and nonsensical. Throw away your cars, they can't run anymore. Scientists said, puzzling observations in the orbital period of Mercury. Further investigation warranted. Because of that, Einstein had a basis for his mathematical work on relativity. Because of that, we now understand some really fundamental things about the nature of reality that we wouldn't have understood without that. And we also still have Newtonian physics. There are other things that have been the scientific consensus that are just plain wrong. I mentioned one earlier, the geocentric model. Everything goes around the Earth. Just plain wrong, right? On the other hand, there were some clues then that it was just plain wrong. The model, the geocentric model, said everything moves in circles around the Earth. And then people observed, because scientists observe, they look at real world evidence, they look at facts, and they try to figure out why. They try to form a model called a theory of why those facts are happening. And when they looked at the facts with their clumsy 16th century telescopes, they looked at where the planets were at different times, and they found out that they weren't moving in circles. No. Actually, they were. You see, they were moving in a big circle, and then there were these little things called epicycles, which were little circles that were attached to the big circle, like a spirograph. You ever play with a spirograph? You're moving a little dot inside one circle, inside a bigger circle, and sometimes as you're rolling it along, the pen goes backwards and makes a little backwards loop, right? How many people have played with a spirograph? Great. So you know what I mean, a little backwards motion. You're rolling the big wheel forwards, and the little pen point is going backwards for a while. Because that was the observation they were getting when they looked at the heavens. They were watching planets appear to move, and then move backwards, and then move, and then a while later they'd move backwards. And so they made a spirograph model of the universe. And it turns out that the epicycles needed additional epicycles. And the more precise the models they made, the more epicycles they had to add onto their epicycles. This kind of ever-burgeoning complexity is actually a bad sign in science. It suggests that you may be patching an inaccurate model rather than re-architecting your model from the ground up. I just made a computer science joke, if you know if there's a programmer. Okay. And it turns out that the reason that they had these epicycles on epicycles on epicycles is that planets don't actually move in circles. In fact, there was never any reason to believe that they did. The reason that scientists assumed they moved in circles is because circles were more perfect. This goes all the way back to the Greek geometers. Circles were perfect. Yeah, perfect. So of course planets, being heavenly bodies, had to move in circles because they were perfect. Planets move in ellipses, they move in ovals. And as soon as scientists realized, I think was it Tycho Brahe? Some astronomer realized that planets could maybe move in ellipses and applied that information, and suddenly it all made sense. The numbers added up. You had equations that could actually describe where the planets would be without saying, oh, now our circles have circles and little circles have lesser circles upon their backs to bite them. It was a better theory. It was a simpler theory that more closely matched the evidence. And people went with it. That doesn't mean that the people who believed that that everything went around the Earth were dumb or lying to people. It was the best theory they had at the time. It was also comprehensively falsified by later evidence. But things like that have gotten rarer and rarer as the practice of science has built a history behind it. When that started happening, science, the scientific method, was still a relatively new innovation. Eva, when did Francis Bacon write about the scientific method?
I'm sorry, I don't know, but he was contemporary with Shakespeare.
1500s. In the 1500s, people actually started articulating an algorithm for formalizing objective knowledge. Prior to that, people observed things, people wrote them down, people wrote down ideas. But they also wrote books full of things like, in China, people walk around on their heads. And there's this place down in Africa where there are people with snakes for arms. And, jaguars have 2 heads and no teeth. They wrote that down because they had no basis for deciding what was a reasonable, what was an unreasonable claim, and because it was difficult to get reliable information from more than a few hundred miles away, and because they didn't have a printing press to make it easy to broadly to propagate their information to a wide audience. Starting in the 1500s, we had the printing press, and we had people articulating a formal method for defining what it is to know something objectively. You make a theory, you make a hypothesis that makes a prediction. You do the observations and you see if they match the prediction. If they don't match the prediction, you throw the hypothesis out. If they do match the prediction, you make another prediction. You test that. After you've made a whole bunch of predictions from the same hypothesis, and none of them have been false, and you've looked as hard as you can for an observation that falsifies that hypothesis, you might start calling that hypothesis a theory. Now, I have a theory. The butler did it. That is not a scientific theory, that is an opinion. There's a linguistic confusion around the word theory. If anyone ever says to you, oh, but that's just a theory, they don't understand science. That is a statement of ignorance of how science as a process works. Because gravity is just a theory. The quantum mechanics that make the hardware right on the borderline between classical electronics and quantum mechanics that makes your iPhone work, that's a theory. Okay? There's a fact that when you make your silicon traces in your integrated circuits any smaller than that, you start having electrons teleporting between them. That's a fact. We can observe that happening. All right? That's the quantum limit on the size of the circuits in your cell phone. But the why that happens, that's just a theory. Gravity, just a theory. Relativity, just a theory. Evolution, just a theory. If you say just a theory, you are failing to understand how scientists use the word theory. A theory in scientific parlance is a hypothesis that has made useful predictions for a long time without being falsified, in spite of thoroughgoing, repeated efforts to falsify it. All right? Now, There have been cases where science came up with a conclusion that was flat out wrong. Andrew Wakefield, British physician, published a remarkable study back in the 70s, proving with really solid evidence that vaccines caused autism. How horrible. This thing that had been credited with saving so many lives, that had in fact saved so many lives, was nonetheless causing our children to grow up thinking differently, and in some cases unable to communicate at all with their parents. It's heartbreaking. Children with severe autism, a lot of them can't even hug their parents. Those of you who are parents, imagine having a child that you love who can't talk to you and can't even let you hug them. They scream and cry and hit you when you try to hug them. What a heartbreaking disease, and it was caused by vaccines, and Wakefield had the proof. If you think there's any possibility that vaccines cause autism, please be unafraid and raise your hand. Okay? Vaccines don't cause autism. The scientific consensus, based on thousands now of studies, is that there is absolutely no scientific evidence that vaccines cause autism. There's no mechanism by which they would. There's no evidence that they do. But what about Wakefield, you ask? He lied. He flat out made up his data and wrote a fraudulent study making a false claim that vaccines cause autism. Science gets it wrong. Well, no, actually, science got it right. Science looked at that fraudulent claim and researched the hell out of it over the next 25 years and kept coming up with, no, we actually were unable to replicate this. We don't see any relationship. When we look at thousands of children, there's no relationship between vaccination and autism. What's going on? And it turns out that Wakefield's research was funded by lawyers who were suing vaccine manufacturers on behalf of parents of children with autism. And he made up that data, and he made up that study because he got paid for it. He got paid quite well for it. He got I think $250,000, about $670,000 in funding to do that research.
In the 70s?
And in the 70s, as Eva points out, in the 70s that was a lot of money. It's still a lot of money. How many people did Wakefield kill?
Many.
Wakefield is one of the more successful serial killers in history. His lie, which he told for money, has killed thousands of people and continues to kill them today. If you look at the money that has been wasted, all of those studies trying to find a link between vaccines and autism could have been used researching what causes autism and how do we treat it more effectively. Could have been spent researching better vaccines. All of that money was wasted, and that's millions and millions, and probably billions by now, of dollars, and thousands of lives, because Wakefield wanted to be rich. Science didn't get that one wrong. The scientific community responded to that with, wait, seriously? Really? Wouldn't we have noticed that before? We'd better read. No, they didn't. The scientific community did not respond with, Wakefield's a liar, chase him out of the temple with whips. The scientific community did not respond with, well, we made vaccines, so they must be perfect. The scientific community responded with, oh my God, we need to find out about this right now. Children could be being permanently damaged by these life-saving treatments. And the scientific community, over time, once all of the data was in, correctly concluded that Wakefield had lied. The medical journal that published Wakefield's article published a retraction. Wakefield is no longer, is he still alive even? I don't remember.
I think he's still alive, but he doesn't have credentials anymore because it was demonstrated that he had faked it.
Yeah, they went back to the original sources and they found that he had just made up the data, and he is no longer a practicing scientist. He still has the $670,000, whatever of it he hasn't spent.
And a huge following.
And a huge following of people who go, oh, poor Wakefield, hounded from the field of science by the true believers of science. None of that's true. He lied for money. Thousands of people died. Millions or billions of dollars were wasted. And he got away with it more or less scot-free. But science Science investigated those claims rationally and built a scientific consensus that vaccines do not cause autism. They just don't. Mercury-containing vaccines don't cause autism. Non-mercury-containing vaccines don't cause autism. Autism is not caused by vaccines. Vaccinate your kids. Okay? How about tobacco? Science used to say that cigarette smoking was completely safe. There was a time period in the, I think it was 40s and 50s, when science said, smoking cigarettes is great for you, causes no problems. Well, sadly, it turns out that the studies showing that cigarette smoking caused no problems were funded by the tobacco industry, which had known internally from the 1940s that cigarette smoking caused lung cancer and emphysema. The cigarette companies knew. That's why they funded the research that claimed that cigarettes were harmless. So when you're looking into the scientific consensus on something, follow the money. It really makes a difference. Who gets rich from the theory of evolution? Paleontologists are not living in million-dollar homes. I hate to break it to you. Okay? Paleontologists do not have well-funded departments where they can always afford to go where the fossils are found and dig them up. There is not a lot of money in believing in the theory of evolution. But oh boy, is there a lot of political power and money in denying the theory of evolution. There are always rich conservatives willing to fund evolution denialist research. There's actually no evidence behind it at all, sadly. What about global warming? Does James Hansen of NASA get rich by going, oh my God, we're melting our planet? I'm paraphrasing for dramatic effect. He doesn't actually say that. What he actually says is things like, anthropogenic causes appear to be intrinsic to the recent increases in global temperature as measured by the global temperature tracking, blah, 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 because he's a scientist. Does James Hansen get rich by preaching global warming, by providing data about global warming? He does not. But the oil companies, the fossil fuel companies, which it now turns out have had internal research showing that global warming is real for the past 30 years, they make a lot of money over being able to sell a pollutant that is damaging our ecosystems without paying any penalty for it. So follow the money. In the absence of money issues, you can pretty much go with what the scientists in aggregate say. 97% of scientists in fields like climatology and meteorology, 97% of them say, yes, human technological activity has changed the climate, is changing the climate. 97% is a ridiculously high percentage in anything. I personally find it useful to just assume there's a 10% lunatic fringe everywhere. Okay? And yet 97% of scientists in those fields agree that global warming is real, by which I mean that anthropogenic climate change is supported by the evidence. Okay? By the way, anthropogenic climate change is supported by the evidence? Let's all get a rousing chant of that. Anthropogenic climate change is supported by the evidence. Anthropogenic climate change is supported by the evidence. Wow, you guys are good. You almost got a chant out of that. Right? Global warming is a hoax. Global warming is a hoax. Global warming is a hoax. It chants a lot better. Right? Just like Trump that bitch chants a lot better than Stronger Together. Okay? Be careful what you believe. It's a lot easier to phrase things appealingly if they are jingoistic and appeal emotionally than if they are accurate and appeal to your reason. It's one of the problems we face as rationalists. It's very hard to make science sound as sexy as science denialism. Okay? If you look at all of the major scientific controversies of our time, you will find that they are political controversies or economic controversies. Science doesn't spend a lot of time or effort having controversies. Science has opposing theories. Very, very rarely, some theoretical physicists will come to blows over whether the many worlds interpretation or the Copenhagen interpretation of quantum mechanics is more correct. But they have to be pretty drunk at the time to do it. And they're certainly not, taking out full-page ad campaigns going, many worlds is obviously lunacy. No, they're going to doing research and making experiments and trying to come up with hypotheses that differentiate between them. Because scientists in general, scientists, human beings, so anything I say is a generalization, scientists in general are much more invested in convincing people by the scientific method and by reason, and in fact convincing themselves of the truth, than in being right. How many people here like the feeling of being right? How many people here like the feeling of learning they were wrong? Fewer, and I'm only half-heartedly raising my hand here. I've had to work really hard to learn to like the feeling of being wrong. It is natural to human beings to like the feeling of being right. Being wrong is an acquired taste. But acknowledging that you were wrong, learning to like the taste of being wrong, is the only reliable strategy for becoming less wrong. If you are addicted to the feeling of being right, as humans start out, our natural state is loving being right. You are closed, you're going to resist anything that makes you wrong. Anything that gives you the unpleasant feeling of going, wow, I was wrong. Sorry, guys. Looks like that statistical correlation was actually just a statistical artifact, and this paper that I got famous for, I'm going to have to retract it because all of our follow-up studies showed that there was no relationship. I'm really sorry. That's a hard thing for anyone to say. You can tell good scientists because they're very cautious about what claims they make, because it's really embarrassing to have to say, hey, I was wrong. And if you make a big claim and it turns out to be false, a good scientist stands up and says, hey, I was wrong. Okay? When you look at a controversy in the media, you will almost always, you will reliably find money or political power behind the existence of the controversy. The science is generally either unambiguous or very ambiguous, and scientists are still quietly beavering away, trying to chew down the giant tree of truth, trying to find out which side is true, right? Not trying to prove their own side true. A skilled scientist tries to disprove what they know. You guys know why? All it takes to disprove a hypothesis is a single counterexample. If I have a belief, and you can find even one counterexample, my belief must be false. You can know that something is false. But if I have a belief, it doesn't matter how many examples of its truth I can find. I don't know that it's true. There could still be some counterexample lurking out there somewhere. We had a lot of proofs. We had a lot of evidence that did not contradict Newtonian physics. All it took was the orbital period of Mercury to prove that Newton was wrong. The orbital period of Mercury disagreed with Newton's predictions, so Newton was wrong. As soon as those measurements of the orbital period of Mercury were reliable enough and had been repeated enough times that we were really sure that it wasn't just measurement error, it wasn't just someone having a slightly inaccurate watch when they measured where Mercury was, or a slightly inaccurate protractor to tell what angle Mercury was at. As soon as that data was in, we knew Newton was wrong. We didn't know what was right yet, but we knew Newton was wrong. Science can disprove things. It cannot prove them. And this, by the way, is what's at the root of the, oh, well, that's just a theory. People who say, oh, that's just a theory, are looking for truth. No, are looking to have found truth. Scientists are looking to disprove the truths they think they've found. Because they can do that. Because it is theoretically possible to disprove something, and it's not actually possible to prove something. There could always be a counterexample waiting around the corner. We're really happy with the theory of relativity. Einstein's theory of relativity has made many, many predictions having to do with what we'll observe when a satellite moves really fast and we're watching electromagnetic waves from it. It makes lots of predictions of what we'll observe when a star goes behind a black hole, right? And even when they're very counterintuitive. For example, if a galaxy, if you guys are Earth, and this is a galaxy, and a black hole moves between you and the galaxy, what do you see?
Many galaxies.
You see a ring of light. You see multiple galaxies where there should be one, and they all have exactly the same spectrum. They're exactly the same galaxy, because the light from that galaxy is being bent around the black hole. Dude, there is no force on Earth that can bend light in free flight. We don't have access to that kind of gravitational gradient. We don't get to bend light. But we can look out into the sky and observe light being bent. The theory of relativity, really awesome. Lots and lots of evidence. Did you know that there's actually some observations that contradict the theory of relativity? There are places in the halo of objects around certain galaxies where the matter we can observe moves at different speeds than we think it should. Different speeds than relativity predicts. And we don't know why. There are some great theories. There's the dark matter hypothesis, which says there's stuff that has mass but nothing else. It doesn't block light, it doesn't block electromagnetic radiation, it doesn't emit electromagnetic radiation, it just has mass, and there's a lot of it. If dark matter is the answer, then only about, I think it's 5% of the universe is the matter we see and interact with, and 95% is dark matter, dark energy, and antimatter. We don't know for sure. Another theory is that there is another force, a fifth force, that works at very large distance scales. It's a very, very weak repulsive force, right? Another hypothesis is that gravity works differently at very long distances, right? We've finally, after more than a century since they were predicted, we have observed gravity waves. We observed the collision of two neutron stars and the resulting wave in the fabric of space-time. That's exciting. Now, doing that required building a special observatory whose sole purpose was to measure whether it had two laser pads at right angles. And they were, I think, hundreds of miles long?
I think it was 4 kilometers each
Okay,
arm.
I'm sorry, thank you. 4 kilometers, that's why I love scientists, because you guys correct me when I'm wrong. 2 arms, 4 kilometers long each. And a gravitational wave would stretch one of them more than the other. It would actually change the distance between them, not by moving them further apart, but by making the space in between them longer. And because, yes?
Just to add, the accuracy was 1/1000th the diameter of a photon was, they could measure that difference.